On October 29th, 2025, something changed in the solar system. The sunrise looked the same, the planets glowed as they always had, and space seemed silent. But behind the blinding glare of the sun, hidden from ordinary sight, a traveler from another star was about to make history. The interstellar object known as 3I Atlas had reached perihelion, the closest point in its orbit to the sun. Astronomers expected the usual show, a steady brightening, a graceful tail of vapor and dust, the quiet chemistry of ice surrendering to heat. What they witnessed instead was chaos. Within hours, Atlas's light didn't just increase, it erupted. Its luminosity doubled faster than any known comet in recorded history. Telescopes across the world filled with data that made no sense. At Lowell Observatory, Dr. Chi-Chong Zhang's voice crackled over the radio. It's exploding. But explosions leave wreckage. This one left nothing. No fragments, no plume, no expanding debris cloud. The light wasn't scattering, it was radiating. The object hadn't shattered, it had transformed. Astronomers scrambled to explain what they were seeing. A comet's outburst is supposed to release gases and dust in random directions, a chaotic process of internal fractures and venting jets. But 3I Atlas wasn't chaotic. The outburst was symmetrical, light expanding evenly in every direction, a pulse of energy that looked almost choreographed. Natural events don't behave like that. For a moment, the word explosion didn't fit anymore. It looked less like destruction and more like reaction. In the hours that followed, observatories recorded a torrent of new data. Radio telescopes detected jets of water vapor blasting from the object 5.7 times 10 to the 28th molecules every second. 40 times the rate measured just weeks before. That's the mass of a mountain turning to vapor every heartbeat. Spectrographs showed violent spikes of carbon chains and nitrogen radicals, the chemical fingerprints of ice sublimating faster than any comet ever observed. But even that didn't fit the pattern. Normally, brightness builds gradually as a comet approaches the sun. This one didn't build, it pulsed. A flat line, then a single heartbeat of light, then silence. Dr. Carl Bams at the Naval Research Laboratory called it watching a candle turn into a flare gun. The geometry made no sense. For the outburst to appear that even, the energy had to release across the entire surface at once. Comet vents burst unpredictably. This one released energy like a perfect sphere. The physics of that shouldn't exist. The deeper astronomers looked, the clearer it became. 3I Atlas wasn't breaking apart. It was doing something controlled. Images from NASA's solar observatories SOHO, STEREOA, and GOES-19 soon arrived. They expected a glowing arc of dust and vapor sweeping behind the object like every comet near the sun. Instead, 3I Atlas had no tail at all. It appeared as a stretched ember, bright but contained, drifting through the solar wind as if the forces shaping every other comet had stopped working. It looked wrong. Radiation pressure from the sun should have blown particles away for millions of kilometers, but the object stayed intact, unbothered by solar wind, unmoved by gravity's usual grip. At first, scientists thought it might be a trick of perspective. Maybe the dust was too fine to reflect sunlight. Maybe the eruption expelled gas without solid material. But the pattern held. Days passed, and the brightness stabilized. The object that should have disintegrated at perihelion remained whole, glowing with a kind of quiet intensity that seemed almost deliberate. Theories came fast. Some said that trapped carbon dioxide had frozen the surface to an extreme degree, insulating the nucleus until it suddenly burst. Others proposed that internal pressure had built up for millennia, finally breaking through a hardened crust. But even those theories couldn't explain the symmetry, the way energy released so perfectly across its surface. Random systems don't produce such precision. Then, the James Webb Space Telescope turned toward it. Using its infrared spectrograph, Webb peered through the coma, the hazy shell of gas surrounding the object, and what it found shocked everyone. The surface of 3I Atlas wasn't ice. It was something else entirely. Webb's data revealed a crust infused with complex polymers, materials formed by billions of years of exposure to cosmic radiation. The outer layer had been hardened by time itself. Molecules shattered and recombined by constant bombardment from supernova particles and black hole jets. The result was a shell unlike anything in the solar system, stronger than stone, darker than soot. Simulations from the Royal Belgian Institute for Space Astronomy suggested radiation had penetrated 60 feet deep into the nucleus, altering its chemistry from frozen water and carbon monoxide into long, durable chains of carbon. This crust absorbed sunlight instead of reflecting it. It stored heat, and when that energy reached a threshold, the shell gave way in one instant. The explosion wasn't a failure, it was release. One researcher described it as the universe opening a vault. Inside that vault might be material older than the sun, chemistry preserved since before our solar system existed. But the phrasing that caught everyone's attention came from Dr. Roma Mazzio, the lead spectroscopist on Webb's observation team. She said, "Calling it a failure might be wrong." The timing was too perfect. It might have been an activation. That word spread like static through every observatory on Earth. Activated. If radiation forged a crust this durable, what if that same process changed more than just the surface? What if the whole object had been transformed? From frozen rock into something self-stabilizing, something that reacts to energy rather than succumbing to it. The question haunted the data teams. The readings showed no metallic compounds, no alloys, nothing technological in the human sense. And yet, the precision of the event felt engineered. Then came the question no one wanted to ask. Could an object survive 12 billion years adrift in interstellar space, passing through star systems, absorbing cosmic energy, and remain intact by accident? Or had radiation over countless eons turned it into something self-reinforcing, a kind of natural machine created by the universe itself? At Harvard, Professor Avi Loeb demanded transparency. He urged NASA to release every raw frame, every data set, every line of spectral analysis from 3I Atlas. His argument was simple. Whatever this object was, humanity deserved to see it. But his tone carried a different weight. It wasn't conspiracy, it was urgency. The world had just witnessed a frozen relic from another galaxy erupt in perfect symmetry, survive the sun's fury, and glide away untouched. If 3I Atlas really did activate, then it didn't just explode near the sun. It woke up. And for the first time, scientists began to wonder if the traveler from another star had a purpose, one we just weren't ready to understand. In the weeks that followed the explosion, the world's telescopes kept their eyes on 3I Atlas. Its glow was fading, but its mystery was deepening. The James Webb Space Telescope had gathered enough data to map what the naked eye could never see: the scars beneath the light. As the first infrared reconstructions came through, the image was astonishing. The object wasn't cracked or fragmented as expected. It was whole, reshaped, almost polished by the event, its surface smoother than before. It was as if the outburst had burned away imperfections instead of destroying them. The data suggested something more unsettling. The composition of the surface had changed. Before perihelion, the readings showed common cometary signatures: frozen carbon dioxide, water ice, ammonia. After the explosion, those markers were gone, replaced by dense polymers and long carbon chains, molecules that don't form naturally in a single event. It was as if the blast hadn't released energy, but reorganized it, transforming matter in ways no known chemistry could explain. At NASA's Jet Propulsion Laboratory, the conversation shifted from what happened to why. The models all failed. Every simulation ended with either fragmentation or complete disintegration, yet the real object was still intact. Some engineers whispered that the outburst looked like calibration, not destruction, a controlled reaction timed to a specific threshold of solar energy. Every spacecraft humanity has ever built carries triggers like that. Systems that wake when sunlight hits the right angle. What if 3I Atlas worked the same way, but on a scale beyond anything we could design? James Webb's spectrograph readings showed something else no one expected. Trace elements of formaldehyde and glycine, simple amino acids formed only under very specific conditions. They shouldn't exist in those quantities unless the chemistry inside the object was self-regulating. Some scientists began to wonder if the energy pulse at perihelion wasn't random but biochemical in nature, the activation of a dormant process buried for billions of years. Professor Avi Loeb, who had followed 3I Atlas from its discovery, made a statement that echoed across the scientific community. If this object behaved like a machine, then perhaps nature has been engineering longer than we have existed. His comments were controversial, but they reflected what many already suspected: the symmetry of the explosion, the restructuring of the surface, the absence of debris. All of it looked less like an accident of physics and more like an execution of design. Across the world, researchers proposed theories. Some claimed the object had been a failed planetesimal, a seed from a long-dead star system that never became a world. Others believed it was a storage vessel, a relic carrying chemistry older than our sun. But a growing few suggested something far stranger. Maybe 3I Atlas wasn't just a rock shaped by time. Maybe it was an artifact shaped by intention. At the Royal Belgian Institute for Space Astronomy, Dr. Roma Mazzio's team simulated the long-term effects of cosmic radiation on interstellar ice. Their results showed something astonishing. Under enough exposure, frozen materials could evolve structural properties. In other words, radiation didn't just damage the object, it could teach it. Over billions of years, the chemistry of survival might turn into something like instinct. Matter could learn to react, to adapt, to respond. If that was true, then 3I Atlas wasn't just an object anymore. It was a survivor, a traveler carrying the memory of its own endurance. Meanwhile, scientists studying the brightness curve noticed something else. The eruption hadn't faded the way a comet's would. Instead, the luminosity leveled off into a faint pulsing rhythm, one beat every few hours. When the pattern was translated into frequency data, the pulses aligned with the same periodicity as the explosion's energy curve. That meant the pulse wasn't random light. It was the same signal repeating, an echo of the event. At first, they thought it was heat radiation trapped beneath the crust, slowly leaking through fractures. But when the pulse was compared across multiple instruments, it didn't weaken with distance or delay. It was synchronized. The object was emitting in a fixed pattern, steady and deliberate, like a heartbeat in the dark. That discovery reached the Deep Space Network, and for a brief moment, the entire array of Earth's most sensitive antennas turned toward the object. They listened. What they received was faint but undeniable, a repeating spectral signature at the same frequency as the light pulses, traveling across radio bands in perfect phase. The energy source wasn't decaying. It was stable, consistent, and intentional. NASA didn't comment, but inside the network, engineers noticed something even more chilling. The signal wasn't just coming from the object, it was interacting with its surroundings. Tiny fluctuations in the sun's magnetic field matched the same intervals as the pulses. The pattern appeared in places it shouldn't, in static, in instrument noise, in systems that weren't even tuned to the same frequencies. It was as if the echo had spread, resonating through the electromagnetic background itself. The more the object was studied, the less it felt like a comet, and the more it resembled a process, something happening rather than something being. The data teams called it the activation hypothesis, the idea that the explosion was a trigger event that unlocked a hidden sequence of reactions. If the object had been dormant for billions of years, absorbing radiation, maybe the sun wasn't its destroyer. Maybe it was the key. For astronomers used to predictable equations, that idea was terrifying. Space isn't supposed to do things with purpose. Matter isn't supposed to behave like memory. But everything about 3I Atlas defied that rule. By mid-November, the object began to fade from optical view, retreating back into the black front from each pulse didn't just radiate outward, it curved, bending around gravitational fields as though anticipating them. That shouldn't be possible. Light travels in straight lines unless distorted by massive objects. But 3I Atlas's pulses weren't being distorted. They were self-correcting, adjusting for the curvature of space before it happened, maintaining a perfect spherical pattern at all times. That would require knowledge of the future path of every planet and star around it. It wasn't reacting to gravity, it was predicting it. Around this time, the global scientific community went silent. Public data streams vanished, and observatories stopped releasing their nightly reports. The official explanation was system maintenance. Unofficially, it was fear. Whatever was happening with 3I Atlas had moved beyond astronomy. It had become a matter of planetary defense. Inside NASA, the term activation event replaced outburst in all internal memos. The assumption was no longer that the explosion at perihelion was random. It was the first stage of a process, something that had to reach the right proximity to a star to begin. The energy pattern matched a kind of controlled ignition, what engineers might call a power-up sequence. The object had absorbed solar radiation for billions of years, storing it behind a crust of radiation-forged polymers, and when the pressure threshold was reached, it released everything in a single calibrated burst. It didn't die near the sun, it woke up. If that was true, then the countdown wasn't a clock. It was a synchronization timer, an alignment cycle between whatever intelligence governed 3I Atlas and the solar system it had entered. The numbers pointed toward one inevitable conclusion. On March 17, 2031, Earth would be perfectly positioned within the object's projected orbital plane. Some theorists believed it was a navigational maneuver. The object was adjusting its trajectory for a return pass near our planet. Others thought the pulse was an information transfer, a signal so vast it could only be sent through gravitational alignment, when space itself acted as a lens. The most unsettling idea came from the physicists studying the spectral harmonics. They discovered that embedded in the pulse pattern were sequences of ratios identical to those found in human DNA, the same repeating intervals that code for the structure of life. That could be coincidence, a mathematical convergence, or it could mean that the signal wasn't just interacting with the solar system, it was targeting us. For months, small groups of independent astronomers tried to track the signal after official access was cut off. Some succeeded. What they found confirmed the worst suspicions. The pulses had begun splitting, one slightly leading the other, like two signals phasing in and out of sync. When those frequencies overlapped, they produced low-frequency beats that could be detected even by ordinary radio receivers. Anyone could pick them up with the right equipment. The pulse of something that might have been alive, repeating in the emptiness every few minutes. One night in December, James Webb captured its final image of 3I Atlas. The object was a faint spark near the edge of its detection range, but the infrared sensors saw something no one expected. The surrounding space wasn't empty. A faint distortion, like a ripple in heat haze, encircled the object. Geometry in the dark, invisible to normal light, but undeniable in the data. The shape wasn't spherical anymore. It was expanding. NASA never released that frame. The image leaked weeks later through encrypted channels, and those who saw it claimed the distortion wasn't random. It had structure, spiral arms like a galaxy in miniature, radiating from the object's core. Whatever it was no longer a comet, no longer a frozen traveler from another star. It was something active, growing, perhaps unfolding. And through it all, the pulse kept coming. Every 247 seconds, another flash. On Earth, the ionospheric resonance continued to strengthen. Sensitive magnetometers began picking up small but measurable oscillations synchronized with the signal. Power grids registered harmless but repeating surges at the same interval. The pattern had reached us, threading through the electromagnetic hum of the planet itself. Avi Loeb, the scientist who had once called 3I Atlas technologically suggestive, broke his silence one final time. He wrote, "We are listening to something older than our sun, something that learned to endure the universe long before we were born. It is not coming for us. It is waiting for us to realize that we were always part of the same equation." No one knows what will happen when the countdown ends. maybe nothing, maybe everything. But one truth is impossible to ignore. 3. I-Atlas defied every rule we thought we understood. It glowed without heat, moved without propulsion, survived the sun, and then began to sing. And even now, as it drifts beyond the reach of light, the signal remains. A heartbeat repeating through the void. It is faint, but it's there, hidden beneath the noise of space, steady, patient, and precise. Whatever 3 I-Atlas is, it's still speaking, and the universe is still listening. Every time the pulse returns, it feels closer. It's easy to forget that not everything moving through the dark is dead. Some things wait, some things wake. And some things, even after 12 billion years, remember exactly why they came.